here. Subtends an angle theta with the pole of a concave mirror. So here the rays, a ray incident at pole will be reflected symmetrically, and a ray passing through center of curvature and I need diagrams, no? After reflection, it will be like this. Then another ray, which is incident. Like this, plenty of rays are there. 2 rays will be sufficient to trace out an image. So here, these 2 rays will intersect. Okay, this ray, after reflection, what will happen? Let's not bother here. Okay, now you see this. Another ray, let me consider, which is passing through the focus. After reflection, it should become parallel. Let me extend all these rays. Yeah, now the green color one. After reflection. Okay, this is the overall condition. A ray passing through the focus. I think geometry is correct. Yeah, fine. No, where the image? Okay, this is the image. Little bit thick. I'll show it. Not crossing the somewhere diagram. I'll set right the diagram. Huh? Oh, geometrically we have to draw exact one. Let me try. Okay, this will be the after reflection. This will be the focus. Okay, somehow I adjusted it. Okay, let's get into the image. Okay, this should be the image. These are the ways. There's a method like this will be after reflection. I'll show those arrows also. It will be easy for you to trace it out. What about this? This is the center of curvature. This is the focus. And it is incident at an angle theta. So it should be reflected at an angle theta. This is what the image. Height of the image, I'll write diameter di. The black color arrow, that is the image. The ray should become parallel, no, this one. Yeah, look at this one. This is the image of sun. So these are like a sun rays. They're from infinity, no, almost. They're from infinity. So therefore, they're incident at an angle theta with respect to principal axis. It's asking what is the diameter of this one. How to bring all this one diameter. Now, first of all, what is the magnification formula? V by U. And we should also define this as diameter of the image by diameter of the object. What is the diameter DO is? diameter of sun. What is di? Diameter of image. Okay, clear this. So di is what needed. So m v by u into do. What is v? Object distance. Okay, u is the object distance. What is v? V should be the focal length. And what is u? U should be the distance of sun from the mirror. D naught is already indicated diameter of sun. So now what I do, practically I'm able to measure di. Fine. And I know distance from the sun to the mirror. I know focal length. This is f, no, directly. F we are able to measure. So the diameter of the sun we are able to predict using this experiment. A bright disk will be seen here, not like an arrow, a bright disk here. So what is this? There's a bright disk it is. I think I'll show by yellow color then. That'll be better, no? Y2. Yellow or orange? Orange. I do have orange colors. Should have been thick, little bit thick. I have here only, no? Yeah. So what is this arrow? This is the image of sun. Formed by mirror. It's like it'll be like a disk, bright disk it is. I can show only that as an arrow here. And just based on ray diagram, nothing is there. So we should consider two rays. One, a ray passing through center of curvature will go undeviated. A ray passing through focus after reflection will become parallel to principal axis. A ray incident at pole will strike symmetrically, will get reflected symmetrically. Where these three rays intersect, there will be the position. This will be a bright disk will be formed here. So that is the diameter of the image of sun. Diameter of image of sun. Okay, next one more. Newton's formula for spherical mirror. So it is applicable for anything. I just took concave mirror. No, we'll start like this. Usually in the mirror formula, what are V and U? V and U are image and object distance measured from the pole. No. Now instead, if I have information of the object distance instead of from pole, let it be from focus. So I'll call that as x1. Similarly, look at there's a corresponding image, and where the image is at a distance x2. This is the image. This is the object. We have done all the numericals where the distance of the position of object and image was with respect to pole. Now, if I give the position of the image and object with respect to focus, and let me call that as x1. What is x1? Object distance from the measure from focus. x2 is image distance measured from focus. Tell me like how x1, x2 and focal length f are related. So in the mirror formula, I'll replace this image and object distance by in terms of x1, x2. So what is v? V we can write it as f plus x2. Image distance is f plus x2. Object distance u as x1 plus f or f plus x1. Why negative sign? Because towards right will be positive. Towards right incident ray that is emitted by object will be towards right. So this will be positive. Solving this, so I'll end up with this negative sign will get eliminated. F plus x1 plus f plus x2 product of these two quantities in the denominator, f plus x1, f plus x2. This is 1 by f. Negative signs get eliminated. So then simplification of this will be f square plus fx2 plus fx1. So yeah, this will go on this side, no? And f into this will be 2f square plus fx1 plus fx2. I'll send this f to LHS here. This will be to RHS. So this fx2 will get cancelled, fx1 will get cancelled. 2f square minus f square will be f square. This is called like a Newton formula. What are an x2? Distance of, how we should define x1? Distance of object from focus. What about x2? Distance of image from focus.